Okay, so welcome back, guys. Welcome back to today's lesson on ETABS. In today's lesson, we are going to be assigning the wind load. So you're going to define load patterns. So we have the WX and WY. So under the WX, that is the wind going in the X direction. We'll modify these. Now we have the exposure from extents to diaphragm and exposure from shell objects. This is one we are using because this is easier for us. While exposure to shell objects, all it means is that we are going to create a cladding at the perimeter of the building, and the wind is going to be applied to the cladding. So that takes a lot of time, so we are using the diaphragm. And the next thing we are going to choose is our wind velocity, which is VO. So we can check our code, the Euro code. We can just go to the table of contents. Okay, this is the content, and look for whatever you want. So currently we are starting with section 4, which is on page 18. Okay, so we're starting on section 4, which is on page 18. That is this. So it has given us various things, so you can just go through the code to understand the basic of most of the inputs I'm going to be putting. So our VO, the basic wind speed, the wind speed in Lagos is going to be, wind velocity or wind speed is going to be 33 meter per second. Then the terrain category is in Victoria Island and is very close to the sea, which is going to be terrain 0. So you can see it at this point, terrain 0. Okay, so it's terrain category 0. Okay, so that's why I'm choosing this. Okay, so the next thing we need is to put our orography factor. So this is the orography factor. Orography factor is talking about if it's close to hill or is under the downside. So terrain orography, so it's telling you that whether it's in the hill or is in the cliff, or increased wind velocity by 5% should be taken into the orography factor CO. So the procedure to be used for determining the orographic factor will be given in the national annex. The recommended procedure is given in A.3. So you come down here to look for A.3, that is around here. Sorry, let me scroll up. You can check the table of contents to see it. Okay, sorry, let me check it. A30 is around here. Okay, so numerical calculation for orography coefficients. So as isolated hills and ridges or cliff, the escarpments different wind velocity occur dependent on the upstream, which is equals to phi equals h over lu in the wind direction, where the h is the height and the lu are defined in figure 8.1. So we can see this. So we can see what it actually means. Vmin calculation. So the calculation is square bulk. So I'm just going to use the average value of 1 for it to save our time. So we need 1. Then the turbulence factor K1. So we can go to our code on how to get K1. Okay, so let's go back there. So K1, that's the turbulence factor. Okay, so we have the wind for turbulence factor also, so we can read through it and pick the value you want. So I'm going to use a value of 1.0. so the recommended value for K1 is 1.0. so I'll choose this. You can also check your national annex. I have the British national annex here. You can also check that, so whichever one you want, but in this case I'm going to be using this. Okay, so this is, you can just scroll down and check it. So turbulence factor for K1, so this is so you can read through it and it gives you a value on how to go about it. So I'm using 1 for my turbulence factor also. So let's look for structural factor. So if you don't know where structural factor is, you can just go back to the table of content and look for it. But for my structural factor, I'm going to be using a value of 1 also, mean value of 1. Then the density, as we know, the density is 1.25, so we have that. So my top story is going to be the roof, and my bottom story is not going to be the base, it's going to be the first floor, because the wind cannot go into the ground to affect the base, so I'll leave it on first floor. In case if you have a parapet wall on your roof, you select it and put the height of the parapet wall. But in this case, there are no parapet walls at this place. We are assuming no parapet wall. But for practicality's sake, you put parapet wall to protect it. You protect the roofing sheets against it. But we are assuming there's no parapet wall because we didn't place any block wall on the roof. So we untick this. Now the next thing we are going to do is we are going to have the windward coefficient CP and the leeward coefficient CP. Okay, so we have the windward and the leeward. Now when we mean windward and leeward, let me use the plan on AutoCAD. The windward and leeward means if the wind is coming in this direction, that means this is the windward direction and this is the leeward direction. When the wind goes in this direction, there will be a suction around this place. We are using our windward direction in this place and the leeward is going to be in this place. So we can see what the code is suggesting us to use. Okay, so you can look at it. Okay, we have the internal and external pressure now. We are going to be using this. Let's just read all through. Okay, it has a little graph which we are going to follow, so you can follow all these and it explains what to use for your pressure and force coefficient. So instead of internal and external pressure, let's look at it. So for my windward and leeward, I'm going to use 0.85. Once you see it, okay, so you can look at it. This is it here. So for buildings with H over D greater than 5, the total wind loading provisions is given in this other table. But for others, you can see it. For buildings with H greater than 1, we should use multiplying factor of 1. And for buildings with H less than 1, the resulting force is multiplied by 0.5. So we can see it. Okay, so you can easily pick our table from this. So for example, I want to pick 0.85 is less than this, so I'm going to use 0.7 in this direction. So this is what it means. If the wind is coming in the X direction, as the wind is coming in this direction, and our this is less than 0.25, I will use CP10. Now CP10 is for every 10 meters and CP1 is for small structure like 1 meter. So I'm using 0.7 and minus 0.3. That's what I'm going to use. Okay, so I have this. I'll go there, 0.7 and minus 0.3 in this case. Okay, minus 0.3 in this case, and click OK. Sorry, 0.3. Okay. In the other one, in the Y direction also, I'm going to do something similar to that. That is 33,0111 and first floor. Okay, so I leave the other direction. I'm going to leave my value in this case, which is going to be 0.8 and minus 0.5. So I didn't put negative, so I leave it like that, and I'm okay with that. So you can see your wind direction and exposure width. So once you modify, you can see the stories and everything, the semi-rigid, the width of the building, the depth of the building, the X ordinates, the Y ordinates. Now for my Y direction, I'm going to leave it at 90 degrees. So I'll remove 0 and leave it at 90 degrees. Click OK. Click OK. Then for my X direction, I'll modify it and leave it on 0 degree. Click OK. Click OK. And we are good to go. Okay, so we've applied our wind load to the structure. Once we analyze it, we'll be able to see the force acting at each joint. So thank you for watching today's video on the wind load. If you have any question, you can drop it in the comment section.